Hello students, welcome to Ajay's classes. Today we are going to discuss about the first chapter in grade 9 physics called motion. Yes, it's motion. Whenever you start about motion, we also have a very important thing which is rest. We have to start from rest, then we'll enter into motion. So, as everyone knows, what is rest? Let's see. An object is said to be at rest if it does not change its position with respect to its surroundings with time. That means you will be seeing some object around you, maybe in front of you, or when you go outside of your home, you can see different objects which are not at all changing their position with respect to you as well as with respect to time. That means, for example, a tree, the entire tree, and home, current pole. There are many things which are not changing their positions with respect to time as well as the observer or surroundings. Okay, so then we will call them as rest. They are not at all changing their positions. Next we have motion. Yes, it is that opposite of rest. It refers to the change in position of an object with respect to time. That is the first condition. Next, objects are said to be in motion if they change their position relative to a reference point or frame of reference. It's a new concept, new word that you are hearing, right? Frame of reference. That means there should be some frame of reference with respect to some observer, with respect to reference and time. If the object changes its position, then we will call it as the object is in motion. Here, as you can see, a person is walking. So if you are seeing any person who is walking, you can say the person is in motion, right? Same to same. And also you can see here so many different kinds of motions are happening. You can see the rotational motion here, something like bouncing of balls, and there is some circular motion, and so many things are there that you can observe in this picture. Alright, so let's go forward and understand about the next concept, which is types of motion, right? Yes, so basically we are going to discuss about some few types of motions. One is translational motion, rotational motion, and vibrational motion. So these are the three different kinds of motions that we are going to discuss today. First one, translational motion. Yes, what do you mean by translational motion? Maybe you would have heard about this word, maybe you will be having some confusion. So let's get a clarity on this translational motion. Yes, motion in which all points of a moving body move uniformly in the same direction. That means you have a body which is moving in a particular direction. If that body is moving, the parts, every part of the body is also moving in the same direction with the same speed. Everything is same to same. Okay, every part of the body will be moving in a particular direction. This kind of motion we will call it as translational motion. Example, a car moving on a straight road. Apple falling from a tree. Not only apple, that may be orange also. So if it is falling, it will just fall together. Every part of the fruit it will be together, right? It will not split up. So it will be moving together. A car moving in a particular direction, a ball moving in a particular direction. So all these things we can consider for translational motion. Examples of translational motion. Next, yeah, as we can see the car. Oh yes, if you see even here you can one more thing you can observe that the wheels are rotating. In this condition we have translational motion as well as rotational motion. Okay, let's understand about rotational motion now. Yes, rotational motion. When an object moves around a fixed axis or a point then we will call the motion as rotational motion. Okay, so here example, a spinning top or earth's rotation or a Ferris wheel. I think everyone have enjoyed this Ferris wheel in fairs and all. So now let's understand how. If you consider a Ferris wheel here, you will be having a center point which is fixed, the axis. So axis is fixed. So then all the people are sitting in their own different seats and they are moving in a circular manner. That means they are rotating with respect to central fixed axis, right? And one more thing you can see here, the top. So here the spinning top will be having one particular axis of rotation. With respect to that axis, there will be a rotation of a top. So the only thing you have to remember, some fixed axis will be there. With respect to that axis, there will be a rotation of a object. The one more best example in your real life situations that we can say is fan. So I think who doesn't know, like every day you're watching fan, right? So as you can see, there will be a one point which is attached to the roof, and the fan is rotating with respect to that axis. That axis is fixed to a roof, right? So now we have the rotation of fan with respect to some axis of rotation. Yeah, this kind of motions we'll call them as rotational motion. The only thing is the axis of rotation or the point is fixed. With respect to that point, the rotation will happen. Next, vibrational motion we have. What do you mean by vibrational motion? Even this one is also a basic one. The back and forth or to and fro motion around a central point is also called as vibrational motion. That means there will be some central point. With respect to that central point, there will be to and fro motion or up and down motion or back and forth motion. Whatever the motion, back and forth, up and down or to and fro. To and fro, we also call it as one of the example of simple pendulum. So in the simple pendulum, there will be a to and fro motion, oscillations, but there will be some particular central point. Example, we have a swing, a pendulum swinging, or a guitar string vibrating. Yeah, so the guitar, who doesn't know? Yeah, here. So when you apply a force on a string of a guitar, it starts vibrating in a particular direction. To and fro motion is there, vibration, so up and down. So that one is called as vibrational motion. So finally it will be coming back to the original central mean position, right? So after vibrating up and down, after some time it will come to some central point. Okay, with respect to that point, there will be a vibration. I hope you got it. Let's go forward. Even the tuning fork, if you consider, when you vibrate a tuning fork, even it will be vibrating to and fro. So left side and right side together. Okay, so this is one of the example of vibrational motion. Now we will enter into the next level, which is the concept of scalars and vectors, which is very important. And this is the introduction of scalars and vectors in grade 9, I think, right? Yes. What do you mean by scalars? We will be having so many physical quantities in physics. In that, we are going to divide all the physical quantities into two parts. One is scalars, other one is vectors. Let's understand what is scalar. Scalars are the quantities which will be having only magnitude value, some numerical value. It doesn't have any direction. Remember, only magnitude value will be there. So we will be having so many scalar quantities. For example, distance, speed, time, and so on. There are many other physical quantities which will be coming under scalars. They don't have any direction. They will be having only magnitude values. Yeah. Next is vectors. As we have already discussed, scalars will be having only magnitude. The vectors will be having both magnitude as well as direction. Some of the examples as we can consider, like displacement, velocity, acceleration, force, thrust, and so on. There are many physical quantities which are having both magnitude and direction. So now let us consider two examples from each scalar and vector. So first one, distance and displacement. Okay, so let's understand about distance and displacement now. Yes, what is distance? Distance is something like the total path covered or traveled by an object, irrespective of the particular direction. So the SI unit is meter. Okay, so for example, if someone asks you, what is the distance between your school and home? You will say like 3 kilometers or 5 kilometers, maybe 10 kilometers. You will just say the number, right? 10 kilometers and all. Do you say 2 kilometers north, then 3 kilometers south, then 4 kilometers east, something like that? You won't say any directions, right? You will just say the distance. So that is the distance, actual distance is. There is no particular direction, only magnitude value will be there. So now, as you can see here, a person, a lady is moving from A to B, then B to C. So what is the total distance here? From A to B, 100, B to C, 50. So the total distance will be 150. You can observe this one, right? So the total distance is 150. So first she starts from A, she goes to B, and she will come back to C. Yeah, the total distance will be 150. Next, if we go to displacement. So now the displacement, if you consider, the shortest distance covered by an object is called as displacement. That means the shortest distance. Always the shortest distance will be a straight line. That you have to remember. Okay. If you have a straight line, then we can say it has a shortest distance between any two points. Or also we can call it as the change in position of an object in a specific direction. That means there will be a change in position. So initial position and then final position, right? The change in these two positions will be given as displacement. And SI unit of displacement is meter as usual. Just like a distance, here also you will be having meter as SI unit for displacement. So now let us understand the change in position. What does it mean? So always you have to find out displacement with respect to this formula. Displacement is final position minus initial position. Okay, so now let's understand the value of final position minus initial position, how it will become displacement. And one more important thing is displacement can be 0, positive or negative. So it can be any value, that may be positive, negative or 0. So now if you consider in this same case, a girl is moving from A to B, then coming back to C. That means initial position is A, final position is C. So what is the formula for displacement now? Final position minus initial position. So what is final position? 50. Yes, I think you can see the final position is 50 and initial position is 0. So now 50 minus 0 is the displacement. I hope you got it. That is the shortest distance between the initial and final position. Okay, I hope you got it. Let's enter into the next one, speed and velocity. Yes, speed and velocity. In everyday life, everyday situation, you are going to use this speed word, right? Yeah, so increase the speed of a vehicle, yeah, raise the power, all those things, right? So let's understand the speed. The rate of change of distance is called speed, or total distance covered with a total amount of time is also considered as speed. The formula is speed equals to distance by time. SI unit of speed is meter per second. Okay, so distance will be having meter and time will be having second. So meter per second. So that is the basic idea. Next we have the vehicles which are moving in different speeds, right? So they will be taking left turn, U-turn, right turn and all of the things. It doesn't matter. Whatever the speed is mentioned, the total distance covered divided by time. So why you are seeing this image? That is because you are not considering any direction here. The total distance covering only you are considering, and divide by how much time it will take, you are going to get a particular speed. Yes. Next one, velocity. The rate of change of displacement is called as velocity. As we know, displacement is a vector quantity, even velocity is also a vector quantity. The formula will be velocity equals to displacement by time. Yes, SI unit of velocity is same as speed, which is meter per second. Yes, here you can see all the objects are moving in a particular direction, right? You can see a particular direction, but here magnitude is changing. So there are different velocities for different objects here, but they will be having particular direction and they also have a particular speed. That means speed in a particular direction is called as velocity. Okay, so next we have an example for the same thing. A car traveled 200 km in 4 hours. Its speed is 50 km per hour. But if it travels 200 km north, its velocity is 50 km per hour in north direction. So here measuring of speed, sometimes we will use kilometer per hour, sometimes we will use meter per second. So the SI unit is meter per second. Based on the convention, we will be having 50 km per hour. So kilometer per hour also can be used. I hope you got it. Yes, it's not the end. Next we have part 2 video of chapter motion. Just wait for the video. Until then, keep learning. I'll meet you in the next video.